We're going to start this lesson off by talking about combinations. And the definition of a combination I wrote here on the right-hand side of the screen is a collection of objects from a group where order isn't important. So we're talking about a set number of objects, and we're going to call that set number of objects n. Right? So the n variable is going to stand for the number of those objects in the group total. And then we're going to be selecting a certain number of them out of the group. And that variable we will let be r. Right? So in this a combination and in this formula that we're going to follow, it doesn't matter which order those items are selected out of the group. It just, the number of them matters. And so we see our formula here. We always set it up with the C symbol for combination in the middle. And then the subscripts, the one on the left will be your n value, the total number of objects in the group. Your r will be the number that you're going to select out of that group. And then we just follow this formula right here. That formula, it's a formula, it will always stay the same. So if we try to apply that to number 1 over here, we can see that we have an n value of 6 and an r value of 4. So I'm going to plug those numbers into my formula over here. So n of 6 factorial, then I'm going to subtract the n and the r. 6 minus 4 is 2, and then from there I'm going to take the factorial of that. So this is 2 factorial, and then I'll just multiply it by the r value, in this case of 4. All right, so once we have all of that, then we're going to find 6 factorial and divide it by 2 factorial times 4 factorial. Now remember, there on the denominator, it's not 2 times 4 factorial, it's not 8 factorial. We're going to find 2 factorial, and then we're going to find 4 factorial and multiply all those digits together. So in the numerator, it'll be 6 times 5 times 4 times 3 times 2 times 1. Our denominator, 2 times 1, that's 2 factorial, and then times 4 factorial will look like this. And you can see right away that we're able to cancel all of these numbers with all of these numbers here, because we've got just multiplication in both the numerator and the denominator, so we can just reduce like this. So in the numerator, we end up with 30, denominator 2, for a total of 15 combinations. So if we have, what this is saying then in this problem is that if you have 6 objects and you're going to select 4 of them at a time, and the order can be random, it doesn't matter which order each of the objects is selected in, you will have a total of 15 combinations of items that can come out in groups of 4. Try the same thing with number 2. Here's 1, number 2. Now our n value is 8, our r value is 5. So here's our n, here's our r, and we're just going to follow the formula. 8 factorial, n minus r, so 8 minus 5 will give us 3. And then we're going to multiply that by our r value. So again, numerator, look like this. Then denominator is 3 factorial, and then 5 factorial being multiplied onto that. And again, we can see we've got some things that'll cancel. Once again, the 5, 4, 3, 2, 1 will cancel in the numerator and denominator. So then we just are left with 8 times 7 times 6 in the numerator, and the denominator then will be 6, 3 times 2 times 1. Okay, and so when we reduce this, we get 56 combinations. So when you have a group of 8, total group of 8, you're going to pull 5 objects out at a time. There are 56 combinations of ways that those 5 objects can be pulled out. Now we can take this a step further and talk about scenarios where there are multiple events. So in number 9, well, actually, let me read the directions there. It says find the number of possible 5 card hands. So we are going to be selecting 5 cards, that contain the cards specified in our problem, the cards are taken from a standard 52 card deck. So we have a total number of objects of 52, and we're going to select 5 of them out at a time. And we want to know how many combinations there are. Uh, but in number 9, we want all 5 of the cards to be red. So we need all 5 of the cards to be red, and we need to be able to pull 5 out at a time. So we have 2 events going on, a multiple event. When we have a multiple event happening, there are 2 ways it can happen. So we could have a scenario like number 9, where both A and B have to happen. So event A and event B. So event A and event B have to happen. So not only do they all have to, do we want to pick out 5 of the 52, but they all have to be red. So those are 2 things. When this happens, we can find both combinations and we can multiply them together. So we're going to multiply the combinations. If you have an event where it's either or, so event A can happen or event B can happen, either one, then you add the combinations. And I'll point one of those out when we get to one. So in number 9, though, we definitely have multiple events happening, and we have an and. They both need to happen. Okay, so we're going to need to find the combinations that are possible just in selecting a red card first. So we have 2 possible colors, red and black. So that's going to be our N. And we're going to pick one of the colors. So that is our R. So just to find out what our combination possibilities are for selecting red versus black, that's what we're going to figure out right there. We're going to multiply that by the chances then, the possible number of combinations of selecting 5 of them. So out of a stack of 52, a standard 52 card deck, 26 of them are red, 26 are black. So half and half. So out of the 26, we're trying to pick 5 of them. And so there's going to be a certain number of combinations there as well. All right, so then we're going to find the factorial for each of them. We'll evaluate both factorial. The first one will be 2 factorial. And we're following this formula again over here. Same formula as above. 2 minus 1 is 1 factorial, and then we're going to multiply by r. And then we're going to multiply that by the evaluation of the second combination. So 26 factorial, 26 take away 5 is 21, and then our r value of 5. Now I want to drop down here and show you for a second how you can actually cancel before you do all the multiplication. It makes it a lot easier if you go through and do some canceling first. So I wrote out the factorials. So the same problem up here, I just wrote it out in factorials. So I could multiply them together. Now, instead of multiplying all these, because that's a lot of numbers, starting with 26 factorial up at the top, you can go through and cancel what is common, which we practiced a little bit in the top problems. Down here, I didn't even finish it. I wrote 21 times 20, dot, dot, dot. That means I'm going to keep going all the way down to 1. But that can actually be canceled with the 21 factorial in the bottom, because the 21 factorial is going to be 21, 20, all the way down to 1. So those 2 can be canceled. The end of the 26 factorial and all of the 21 factorial. All right, and then from there, you can see that there's a multiplication sign right here. We're multiplying these, so I can cancel across numerator to denominator. I have a 2 and a 1 here that can be canceled with the 2 and the 1 on this side, which essentially takes that combination out of the picture, because that all now equals 1. And then even further, if I wanted to keep going, I can simplify this 5 with the 25. I can simplify the 4 with the 24 here. So now I've got 26, 5, 6, 23, and 22 in the numerator, and just a 3 in the denominator. When I go through and put that in, which is a lot easier to do, we will end up with a final combination of believe it's, yes, 131,560. So that means that if you want to choose 5 red cards from a 52 card deck, you have possible combinations of 131,560. So let's try number 10. 4 spades and 1 card that is not a spade. If you aren't super familiar with the deck of cards and how many suits and face cards and just the dynamics of a deck of cards, you can look in the textbook on page 690, and it has it all laid out for you and organized for you so that you can get that information quickly. So again, we have an and in the problem. This one's actually very obvious. Number 9 wasn't as obvious that we had an and multiple event, but we have multiple events here. We have 4 spades, and event B, we want 1 card that is not a spade. So we need to first figure out how many combinations there are for just selecting 4 spades. So if you look at that illustration on 690, then you can easily determine that there are 13 spades. So that becomes your N. That's the group of objects we're going to select from. We want 4 of those spades, and so that becomes our R. We're going to try to select 4 of those out. 4 spades and 1 card that is not a spade. So that means we're going to have, out of our 5 card hand, we have 1 card left. So here, these 4 have to be spades. And then we're going to multiply that by the fact that we also want a card that is not a spade. So then out of the remaining cards in the deck, so there's 52 minus 13, there are 39 left that are not spades. We want to be able to select 1 that is not a spade. So we're trying to find the combinations, the possibilities of this event happening. So we'll do our factorial of our first combination. And again, we're just following the same formula that we've been following through this whole lesson. And we're going to multiply that by the second combination. Okay, so let's do some canceling before we move on. I have a 39 factorial, so that's 39, 38, 37, 36, all the way down to 1. And then I have a 38 in the denominator, 38, 37, 36. So you need to be able to envision those lines of numbers. That means that 38 on down can cancel out. So the 38 factorial in the bottom, all those numbers, all 38 of those numbers will cancel with all 38 up here in the numerator except for the 39. So the 39 factorial goes away. 38 through 1 all cancel out, and you're just left with the number 39, the first one in the line. Do the same thing over here. 13. We have 13 listed out all the way down to number 1. In the denominator, for 9 factorial, we have 9 listed all the way out till number 1. So 9 factorial can go away. All 9 of those numbers can cancel with everything up here in 13 factorial except 13, 12, 11, and 10. But everything after that can cancel with this 9 down here. So this one can go away as well. There's nothing left. There's no 4, 3, 2, 1 left to cancel with the 4 factorial, so we're going to have to leave that there. We'll take all 5 of these numbers, 13, 12, 11, 10, and 39, multiply them together, and divide by 4 factorial. So this is what we get in the numerator. 4 factorial is 24, and then I'm going to divide those 2 out, and we'll get almost 28,000 combinations. So almost 28,000 combinations of choosing 4 spades and 1 non-spade out of a 52 card deck. So moving to the bottom of the page, there is a theorem called the binomial theorem that we can use to expand a binomial. And so in number 15, we have 4 x minus 2 binomials. So we have x minus 2 times x minus 2 and 2 more of those for a total of 4 x minus 2 binomials. So if you were going to find the value of this, find the polynomial, and multiply it by multiplying all these together, you would have to FOIL these two, and then FOIL these two, and then combine those trinomials together. So it would be a lot of multiplying of terms together. We can actually use the binomial theorem, which is takes advantage of this combination idea, and we can find the polynomial for x minus 2 to the fourth power without having to do all of the multiplication. So the way this works is it's a little bit abstract, so just kind of follow along, and eventually I think you will kind of catch on to the pattern. It's a pattern that's happening. When you have x minus 2 to the fourth, so when we have a binomial raised to a power, we have to identify a couple of things. The first thing is we need to look at the exponent, because the exponent is actually going to be our n value. So in this case right here in this problem, our n is 4. Our a value is going to be this first term. All right, so in this case it's an x, and then our b is going to be the second term, and we want to take the sign with it. So it's a subtraction sign, so our b is actually going to be a -2, and I'm going to put it in parentheses just so that we don't forget about that negative sign there. And then we're going to go through and find our coefficients on our terms first. So our polynomial, they're going to have each term will have a coefficient right at the beginning of it. So we're going to go through and figure those out first. Those are, we use the idea of the combination with our factorials for this idea. So I'm going to call the first constant c, okay? And it's going to be the same c that was represented at the top of the formula at the top of the page. My n value is 4, so I'm going to put that here, just like we did at the top of the lesson. And then one of the possibilities is that out of the 4 objects, none are selected. So that's going to be the possibility for my first constant. All right, my second constant, so I'm going to leave some space because I'm going to have some other terms here to go with that. My second constant, I'm going to do the same thing. I have 4 possibilities. My n is 4. I'm going to select one of them. All right, I'll leave some space again. My next constant, what if there were 4 in a group and I selected 2 of them? And then we'll just keep going until we get to a 0 on this end as well. Oop. I'm sorry, not a 0. Hang on, I started going the wrong direction with my numbers right here. So I'm counting up 0, 1, 2. This should be a 3, and this should be a 4. Okay. So here I have 4 in the group. I'm going to select 3. Here I have 4 in the group. I'm going to select 4. So these are going to, when I find these factorials, I'm going to have my constant for the terms. So let's do before we do the factorials to find the actual number for the constant, let's go through and do our a term. So my a term is going to sit here next to my constant. And now what I'm going to do is I'm going to set that equal to the fourth exponent. And then I'm going to do it again on the next constant, but I'm going to drop it down by 1 degree. And so on and so forth until I get down here. This would be x to the 0 power. I'm going to write it in. We know it to be 1, but just for consistency's sake right now, until you understand the pattern, I want to write that in there because we're starting with our n and we're decreasing in order until we get to the 0. And then we'll do our b term. Now the b term, we're going to do the reverse. So what I mean by that is I'm going to take the -2, set it right next to there. I'm going to start at 0 now. And I'm going to work my way up by degree until I get to 4. So on the a term, you start with the value of n. This case is 4, and you work your way down. On the b term, you start at 0 and work your way up to the value of the n term, which in this problem is 4. So now we need to go back And because this does not look like a polynomial in the form that we know it to be just yet, but it's getting ready to be, we're going to take our combinations and we're going to actually evaluate them the same way we did at the top of the sheet. So we're going to, for this right here, we're going to follow our formula. Okay, let me write it up here just so we have it handy to view. Okay, and so we're going to follow that for each constant. I'm going to switch colors here while I'm evaluating. So I'm just going to come under this. I'm going to evaluate C with an N of 4 and an R of 0. So that would be 4 prime, not prime, I'm sorry, 4 factorial over 4 minus 0. So 4 factorial, and then it would actually be times 0 factorial if we're being consistent. 0 factorial is always 1. So I'm not going to even bother to write that in there, but that would be there. Okay, so that's going to be the evaluation for term 1. Term 2 will look like this. Again, I'm not going to write in the 1 factorial, even though technically I'm supposed to because of this R factorial symbol up here, but 1 factorial is going to be 1, so I'm not going to bother to do that. 4 factorial over 4 minus 2 factorial times the R value of 2 factorial. 4 factorial over 4 minus 3 factorial, which is 1 factorial. Technically, I don't really need to write that in either. And then that will be times 3 factorial. All right, and then last one, 4 factorial over 4 minus 4 factorial. Again, that's going to be 0 factorial, which will be 1. And then times the R value of 4 factorial here. So 4 factorial and 4 factorial, these are both going to cancel out. I mean, that's 4 times 3 times 2 times 1 in both the numerator and denominator. So those are all going to cancel out to give us 1 here. This is 4, 3, 2, 1. And then this is 3, 2, 1. So the 3, 2, 1s are going to cancel out. And then all you're going to be left with in the numerator is a 4. So there's our coefficient on the second term. Right here, 4 factorial over 2 factorial times 2 factorial. Remember, do not combine these into 4 factorial. If we evaluate that, we're going to get 6. I'm not showing you all the algebra on that one just to save time. And then this evaluated gives us 4. This evaluated is 4 factorial over 4 factorial. Those two can cancel out. And then this 0 factorial, again, just equates to 1. So this right here will be 1. All right, so now I'm going to take those and I'm going to plug them back into our spot here. We're going to take this out. So I'm going to take this out right here on each one. I'm going to put this in. So this is evaluated now. All right, so on and so forth. And so I'm just going to evaluate these in. This is 1. Stick 1 in there. I'm not getting anything new. So here I have x to the 4th. Negative 2 raised to the 0 power gives me 1. Anything raised to the 0 power gives me 1. So this term is done. The first term in this binomial expansion is x to the 4th. All right, then we're going to add to that. I have a 4 here, x cubed, and then negative 2 raised to the first power is going to stay negative 2. So we'll deal with that in a minute here. I'm going to come to the next term. I have a 6, an x squared, and now I have negative 2 raised to the second power. That's positive 4. 4, x to the first, I'm just going to write it as x. Negative 2 raised to the third power gives me negative 8. And then this 1 coefficient that I got from my factorial, x to the 0 is 1. So I've got 1 times 1, and then I have this negative 2 raised to the 4th power, which is 16. All right, so my first term, my last term are as simplified as possible. Now I just need to go back through and do the multiplication that's left. So x to the 4th plus, actually let's just call that minus 8 So x to the fourth minus 4 times negative 2, x to the third, 6 and 4 make 24, x squared, negative 8 and that 4, negative 32x, and then plus 16. So this is the expanded form of x minus 2 raised to the fourth power. If we had gone it through and done all the multiplication there and combined everything down into its simplest form, this is the same polynomial that we would have gotten.